All right, so we'll look at problem set 5, which was on trigonometry, sections 6.4 to 6.6. And the first question said, determine the exact radian measure of each angle. So remember, when it's exact, we're not going to evaluate pi. We're not going to go with decimals. So when we convert to radians, remember we multiply by pi over 180, and we try to reduce it. Well, 15 goes into 75 5 times. 15 goes into 180 12 times. So 5 pi over 12 can't be reduced anymore. If it asked for an approximate measure, we would evaluate pi at 3.14 and multiply by 5 and divide by 12. But here it wants the exact measure. So keep in mind, pi has an unlimited amount of decimals. So we leave it as pi, so it includes all those decimals when it's written like that. Same goes for the next one. Multiply by pi over 180. Try to reduce it. Well, 20 goes into 20 once, so 1 pi, or just pi. And 20 goes into 180 9 times. So pi over 9, or 1 pi over 9. And lastly, multiply by 180, or by pi over 180. Try to reduce them. We might say, well, how many times does 12 go into 12? It goes once. How many times does 12 go into 180? It goes in 15 times. So pi over 15. Next one, determine the exact degree measure of each angle. So that's the opposite. I'm going to multiply by 180 over pi. The pi's will end up canceling out, and we have 360 divided by 5. And when I put 360 divided by 5 into my calculator, we get 72 degrees. And we continue with the next one, 180 over pi. The pi's end up canceling out, so we have 7 times 180 divided by 12, and we get 105 degrees. And the last one, multiply by 180 over pi. The pi's end up canceling out, and we end up with 110 degrees if we evaluate it. So that's the first one. Next one says, the arc length of a circle is measured 22.5 centimeters and has an angle of 4 pi over 3 radians. Find the approximate radius of the circle. So remember that radians are equal to the arc length divided by the radius. So basically what's happening in this case is we have a circle where we've carved out 22.5 centimeters of it. And we've created an angle of 4 pi over 3. We want to know what's the radius in order to make that happen, right? The distance from the center to the outside. So I'm going to fill in those values that we know. Go back. I know that the radians, we know the radians is 4 pi over 3. I know the arc length is 22.5, and I know radius is r. So if I cross multiply here, we get 4 pi r is equal to 22.5 times 3. And if I divide both sides by 4 pi, we get 22.5 times 3 divided by 4 pi. So when I put those into my calculator, I'm going to get 5.37. Because it says to the nearest nearest tenth, 5.4 centimeters. And that's that one. For question 4, it says, a wheel turns at 10 revolutions per minute. So every minute, a wheel goes around 10 times. The wheel has a radius of 12 meters. How fast is the wheel spinning? The angular velocity in radians per second. So remember, angular velocity was like W like that. It was radians. And we want seconds on the bottom. So let's break down what our numerator is going to be. How many radians are covered in 10 revolutions? So 10 revolutions means that we've gone around a full circle, which is 2 pi in radians, 10 times, which is 20 pi. So in 10 revolutions, we've covered 20 pi radians. Right, 2 pi for every time it goes around, and we went around 10 times. In seconds, well, it says that it covered that amount of distance in 1 minute. So that's 60 seconds. So if I reduce that, we get pi over 3 radians per second. That's the speed. That's how fast it's going. If we want to actually put that in terms of a decimal, so we had to put pi divided by 3. This is not an exact answer, but it'd be 1.047 radians per second. So the exact answer would be pi over 3. But if we want an approximate answer, we would put in pi divided by 3. We'd have to round that number, which makes it approximate to get 1.07. All right, as we continue on to number 5. Number 5 says, first state the transformations. So our transformations in this case, a value is 3, k is equal to 2, d is equal to negative pi over 4, and c is equal to negative 3. Remember where the negative pi over 4 comes? Really, it's x minus negative pi over 4. That'll be a shift to the left eventually. But if we're trying to display our transformations or write what they are, well, a value of 3 is vertical stretch by a factor of 3. K, this is a horizontal compression by a factor of 1 over 2. D, this phase shift to the left, pi over 4. And C, that's our shift down, negative 3. So let's go through our characteristics. So period, remember period is equal to 2 pi over k. So 2 pi over k in this case is 2, which is pi. That makes sense because we have our original graph, but it's been compressed, right? Horizontally compressed, which means it's really going to start a little bit later and a little bit earlier. So it means that the period, how long it takes to complete one cycle, is a little bit less. That's why our period is only pi and not 2 pi, right? Smaller. Continuing along, equation of the axis, well, that's the c value, in this case, negative 3. So y is equal to negative 3. So what that means is we have our graph, but it's going to oscillate around 3 below. It's going to go up a certain amount, down a certain amount, and back from that negative 3. And the amplitude in this case is 3. That means that it's going up 3, so the maximum would be at 0, and it's going down 3 from that, so the minimum would be at negative 6. And that's that. So second one, same idea, we'll go through it quickly here. But our a value is negative 1 over 3. Our k value is 1 over 5. D is pi over 3. And C is equal to 10. So the a value of 1 over 3 means vertical compression by a factor of 1 over 3. Also, the negative means that it's been reflected over the x-axis. Right, flip down. K of 1 over 5 is a horizontal stretch by a factor of 5. D of pi over 3 means shift to the right. Pi over 3. And C is equal to 10 is vertical translation, so shift down 10 units. All right, keep going along here. Period, 2 pi over k. Well, I know it's 2 pi over 1 over 5, or 2 pi divided by 0.2, which is 10 pi. And that makes sense because we have a horizontal stretch. That means this part's been pulled out this way and this way away from the y-axis, which makes our period longer. 10 pi sounds good to me. Equation of the axis, that's y is equal to 10. So our graph is oscillating 10 above the x-axis. And amplitude is 1 over 3. Right, so if I want to find my maximum and minimum, well, I know 10 above. So where it's oscillating, it's going up 1 over 3, which is 10 and 1/3, or 10.3. And it's going down from there, which is 9 and 2/3 would be the minimum. Right, up and down amplitude from 10. But that's the question 5. Keep rolling along. find the exact value using either cast rule, special triangles, unit circle, doesn't matter, of each of these. So sine 5 pi over 3 is almost 1 full circle, but we're short by pi over 3. Because if that 5 pi over 3 plus pi over 3 is 6 pi over 3, which is 2 pi, right, a full circle. So in that quadrant, sine is negative. And I got to find out what is the exact value for sine if we're using a special triangle with pi over 3. Pi over 6, we had root 3. We had 2. Whoops, no, we have 1 and 2. So for this one, the opposite over the hypotenuse for sine is root 3 over 2. So that's that one. Cotangent, pi over 3. Well, pi over 3 is in the first quadrant, so I know everything's going to be positive there. So I know the answer is positive something. Then I have to look at my pi over 3, and I'm trying to find cotangent. So cotangent is the reciprocal of tan. So if tan was opposite over adjacent, well, cotangent is adjacent over opposite. So I'm going to look at pi over 3 in the special triangle. The adjacent side is 1 over the opposite side, which is root 3. So if I'm looking for its, if I want to radicalize that, I'll multiply the top and bottom by root 3. So root 3 over 3. Keep going along here. Cos 5 pi over 4. Well, this will be 4 pi over 4, right? 1 full pi. So just a little bit more. So we must be in this quadrant, pi over 4. Because we're bigger than pi by pi over 4, and pi would be right across the other end of the circle. Oops. So I'm looking for cosine. In that quadrant, tan is positive, so cosine is negative. And the cosine of pi over 4 using your special triangles would be root 2 over 2. So negative root 2 over 2 is the answer for that one. Keep going along. Secant, well, that's the reciprocal of cos. Well, I know 12 pi over 6 would be 1 full circle. So we're not quite there. We're only 11 pi over 6. So that means we're short by a pi over 6. So in that quadrant, cosine is positive, while secant is the inverse of cosine, so it's also positive. And then I'm going to find out what is secant. Well, that's hypotenuse over the adjacent side. So I'm going to use that special triangle above. I'm going to look for the hypotenuse of the triangle using the special angle pi over 6. The hypotenuse is 2. And the adjacent side to pi over 6 is root 3. So if I'm to rationalize this, it's going to be 2 root 3 over 3. Right, multiplying the top and bottom by root 3. Tan pi over 3. Well, that just means we went around 1 full circle. Right, 2 pi plus another pi for the 3 pi right here. So on our unit circle, I know that that point is at negative 1 and 0. I also know that tan is sine over cos. Sine are the y values and cos are the x values. So of that point that we have there, the y value is 0. The x value is negative 1, which works out to be 0. And finally, the last one that we've got, sine 3 pi over 2. Well, that's right here. The coordinate here would be 0 and negative 1. So I'm looking for sine. Well, sine are the y values, so in this case it's going to be negative 1. And that's number 6. Suppose the terminal arm for angle theta passes through the point negative 4 and 2. So let's draw that out. Negative 4 and 2 will be to the left 4 and up 2, so maybe somewhere around here. Determine the length of each side of the related acute angle triangle to find the exact values for cotangent and sine. Okay, so let's look at this triangle. Maybe I'll darken it in with green from here, here, and here. Well, I know that this is 4 to the left. I know that it's 2 above. I don't know the radius, but I can get that because I know radius squared is equal to 2 squared plus negative 4 squared. So when I solve these ones through, we get 4 plus 16. I get r is equal to root 20. So that's my radius. So let's take those and we'll fill in what we know. I know cotangent theta is equal to what? Well, that's adjacent over the opposite side. So let's look at our triangle. The adjacent to a related acute angle is negative 4. The opposite side is 2, so it works out to be negative 2. Well, how about sine of that same angle? Sine I know is opposite over hypotenuse. So the opposite of that side is 2. The hypotenuse is root 20. And I can rationalize that by multiplying top and bottom by root 20. And I can reduce 2 goes into the top once, 2 goes into the bottom 10 times. I can even reduce that even more because I know root 20, if you want to simplify it, is 4 times 5. I know I can take the square root of 4, which is 2. And 2 goes into both those numbers as well, so I'd have root 5 over 5. Something like that. That'll be simplified as well. All are equal to the same. This one is the most simplified because we've broken it down as much as possible. Next, we want to write some equations out. So go back to blue. Write the equation for y is equal to cos x if it has undergone the following transformations. So translated up 6. So that tells me c is equal to 6. Translated to the left. So d is equal to negative 2 pi. Vertically reflected. So that means a is equal to negative something. And stretched by a factor of 8, so a is negative 8. Compressed horizontally, by a factor of 6. Let's write our equation for what we've got here. Because it's compressed, you can say 6 or 1 over 6. Different books use different methods, but 6 is the important number that we've got. But we know that since it's compressed, I know that it has to be a number bigger than 1, right? Compressed, k is greater than 1. So factor of 6, well, 6 times bigger than 1. So when I fill in these, we're filling in a cosine. So we're going to have y is equal to negative 8, right? A. Cos 6, which is k. X minus negative 2 pi. So plus 2 pi. And plus 6, because we're shifted up 6. So that's our equation. Second one, same idea. Translated down, so c is equal to 3. Translated to the right, so I know that d is equal to pi. Vertical compression by a factor of 2, so that means a's got to be 1 over 2, because when we're compressed, a is less than 1. So we're 2 times more or less than 1, I guess if you want to think of it that way. So we're dividing by 2. And k says it is horizontally reflected, so I know k is negative, and compressed by a factor of 5. So when we compress horizontally, I know that it has to be bigger than 1, and it's 5 times bigger than 1. So same idea, y is equal to half cos negative 5, x minus pi plus 3. That's our equation. Nine, the temperature T in a city can be modeled by this equation here. According to the equation, what is the maximum and minimum temperatures in the city? So what's going to give me that information is A and C. So basically, I know that my graph has a C value of 13.7. And I also know it goes up amplitude from that. So it'll go up 13.7 plus the amplitude. I also know that it will go down, maybe not that much, but it'll go down 13.7 minus the amplitude. So if I want to find out my maximum, we'll just add those ones together. 13.7 plus 4.2. So when I do that, we get 17.9. So that's the maximum temperature. And the minimum will be my equation of the axis minus the amplitude. So when I subtract those ones, I get 5, 9.5. So that's the minimum temperature in this city. Next, what is the period of this equation? Why does it make sense? So remember, period is equal to 2 pi over k. In this case, k is pi over 6. So we're going to say period is equal to 2 pi over pi over 6. Or another way that we can write that would be 2 pi divided by pi over 6. And when we divide by a fraction, that's the same thing as multiplying by its reciprocal. So the pi's will cancel out, we get 12. And why does that make sense? Well, there's 12 months in a year. And then it repeats. So I would expect it to be 12 months, or a period to be 12 before that cycle repeats. Complete the table of information and then graph one cycle of the transformed function using transformations of the parent function. List the set of new points on the left side. So we're going to fill those in. So x and y. You can fill that in first. A cosine function, I know that it starts at 0 up at its maximum. Then after 90 degrees, or pi over 2, it's down the x-axis. Then it goes down to its minimum. Then it goes back to the x-axis and finally ends at its maximum. So if I'm filling in this information, the amplitude is the a value, 5. Period, well, I know that that's 2 pi over k. In this case, k is 2, so pi. The shift that we see, well, I see that it's been shifted pi over 4 to the right. Because our d value is pi over 4, right? Because it's x minus d. Our vertical shift that we have, well, I see that it's been shifted down 1. That's our c value, -1. Our maximum, well, just like before, it's going to be our equation of the axis plus our amplitude. Maximum is 4 in this case. Our minimum is going to be our equation of the axis minus our amplitude, -6. So let's fill in our new points for the transform function because we have the characteristics. Maybe a different color here. Oops. So I know that to get the new points, I have to have x and it has to be divided by k. In this case, 2. And we're going to add d, pi over 4. For my y values, they get multiplied by a, so 5y minus 1. So let's take our points. So I'm going to take 0 and plug it in for x, and we're going to see what we get. So when I do that, I get pi over 4. Next one, we're going to get, maybe we'll do it here, but next one's pi over 2 divided by 2 plus pi over 4. This works out to be pi over 4 plus pi over 4, which is 2 pi over 4, or pi over 2. So 2 pi over 4. Or pi over 2. Same way to write it. Next one we'll put pi. So next one I'll have pi over 2 plus pi over 4. As I go through it, we see we get, 2 pi over 4 plus pi over 4, get common denominators. And when I add them, 3 pi over 4. So next one's 3 pi over 4. So you might see a pattern happening here. So I see the first one is pi over 4, 2 pi over 4, 3 pi over 4. You can solve the rest of them, but I know it's going to be 4 pi over 4, which is just pi, and then 5 pi over 4. We see a pattern. It's increasing by pi over 4 every time. So how about the y values? I'm going to multiply them by 5 and subtract 1. So we're going to get 4 minus 1 minus 6 minus 1 and 4. So I'm going to plot this onto the grid. So one way that I told you that we can plot this onto the grid, let me choose a different color, is by choosing the smallest denomination that we see. So basically the highest denominator. So I see 4 as the biggest denominator. So I'm going to put pi over 4. 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and so on. So you get the idea. These ones will have them go up by 1, 2, 3, 4, 5, 6, and -1, -2, -3, -4, -5, -6. So let's plot our graph. So pi over 4 and 4, right here. Pi over 2 and -1, right here. 3 pi over 4 and -6. Pi and -1. 5 pi over 4 and 4. And we have one cycle. And that would continue. And so on, both directions. But that's one cycle of our graph. All right, number 12 says, use the graph to state the equation of the function, or the given function, as a transformation of a cosine function. So cosine is important, right? I know that I'm either going to have it start at the maximum or minimum. So the equation is y is equal to a cosine k x minus d plus c. So I need to find all these characteristics. So let's start with a. I know a is max minus the minimum divided by 2. That's one equation you learned in grade 11. Maybe you look at the graph and you say, well, I think the equation of the axis is here. I see the distance to the top is 2, distance to the bottom is 2, and go with that. 2 is fine. But if we didn't know that, well, max minus min. Max in this case is 2, minus the min of -2, divided by 2 is 4 divided by 2, which is 2. A value is 2. Next one we look at is k. So I know that period is equal to 2 pi over k. So I can look at my period. I see it starts at 0 and ends at 2 pi, 4 pi. So 4 pi is equal to 2 pi over k. So if we isolate and multiply both sides by k, it would be like 4 pi over k is equal to 2 pi. Whoops. What am I saying? Multiply both sides by k, we get 4 pi k is equal to 2 pi. And divide by 4 pi, we get k is equal to a half. So we got k, we have a. Next, we look for c. They use the same color. This was to find k. This was to find a. For c, over here, that's same idea. It's max plus min divided by 2. So our maximum is 2. Our minimum is -2 divided by 2. We get a c value of 0. And lastly, our d value. So for the d value, we look at our graph. And I see that it starts right here for a cosine graph up at the top. So I see it's been shifted to the right pi units. So d is equal to pi units. It's been shifted to the right pi units because now it begins here instead of at 0. So that gives me enough to write my equation. We have y is equal to a, which is 2, cosine k we got was a half, x minus pi, d we found was pi, and c value was 0, so I don't have to put 0, but that's our equation for 12 for that graph there. There are different ones, right? You could have said, well, I want it to start at the bottom here and it's going to be a reflected cosine graph. That's fine too. Or maybe start at the bottom here, it's a reflected cosine graph. Different translations, but that's fine. All right, keep going. Number 13. The water depth in a harbor is 17 meters at high tide and 7 meters at low tide. One cycle is completed approximately every 12 hours. Graph one cycle of this function starting at high tide. So, if we had these go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22, And I know that it's starting at high tide at 17, so that'll be right about here. And I know it goes down to low tide of 7. And I know that it has to complete one full cycle in 12 hours. So that means it'll be down at its minimum after 6 hours, because that's halfway. 7, 8, 9, 10, 11, 12. So 12 will be back up at its high tide. So I know it's going to complete something like this. However, I can do a little bit more work. I can find out that the equation of the axis is halfway between those. So 17 plus 7 divided by 2 is 24 divided by 2, which is 12. Equation of the axis is going to be at 12. Line that splits it in half. So when is my graph going to be at those spots? Well, I know that, there's my color. I know that halfway between 0 and 6, it's got to be 3 is where it's going to be at its x-axis. And I know same thing on the opposite side. Halfway between 6 and 12, 9, it's going to be at its x-axis. So I can get a couple extra points actually, because that's just how these functions work. That'll be one cycle. Now what we want to do is find an equation for the water depth at high tide. So basically that graph that I have above, I want to find the equation for it. So let's go through my amplitude. That's the distance from 17 to 12. 17 minus 12. Whoops. Which is 5. I can also do that max minus min. So in this case, it'd be like 17 minus 7 divided by 2, which is 10 divided by 2, works out to be 5. Right? I can either count the distance from here to here, or I can use that max minus min formula. Regardless, I'm going to get 5. My k value, well, my period is 12, so I have to find out what my k value is. So I know that period of 12 is equal to 2 pi over k. So when I isolate, I'm going to get k is equal to pi over 6. And that's that one. My d value, well, I can see that my graph has not been translated to left right. It's starting at its maximum right here. So d is 0. And my c value is that equation of the axis. You can do max plus min divided by 2. I know it's at 12. But if I did max plus min, that's what we showed up at the top. 17 plus 7 divided by 2 is 12. So I can write this graph. We have y is equal to a, which is 5, cosine, k, which is pi over 6, x minus 0, or just x, plus 12. And then depending on how you want to write, you can have different variables, right? We're talking about height of the tide, so maybe h is equal to 5 cos pi over 6, and x could be time, right, in hours, plus 12, right? Because you set the variables for whatever you want. Next, determine the water depth to the nearest hundredth of a meter, so that's 2 decimal places, 5 hours after high tide. So it's saying when time is 5 hours. So if I look at my graph here at 5 hours, looks like it's a little bit above 7, but I have an equation. We can just substitute that in. So we'll do that. I'm going to plug in 5 into the equation. So y is equal to 5 cos pi over 6 times 5 plus 12. So in this case, ask yourself, what does my calculator need to be in? Should it be in radians or should it be in degrees? You should look at it and say, well, I see that we have pi over 6. That's in radians. So I'm going to have my calculator in radians. So we put it in 5 cos pi over 6 multiplied by 5. Whoops. Plus 12. And we get 7.67 meters. So it's not quite at its minimum. it's on the way, the tide is on the way out at that point, right? Because it's on the way down, but 7.67 meters. And that's that equation. So if you have any questions, let me know, but we'll talk soon.